to calculate total value locked? What is Herfindahl-Hirschman index? And what the heck is weighted average volatility of assets? Such long words. Today, we are writing the third category of our point-in-time metrics analysis, TVL and diversity. As always, please visit the link above on the screen if you have no idea what I'm talking about. And if you do, let's get started. First things first, let's quickly cover what are the metrics we will gather in the query today. TVL is the current balance of the safe wallet, so how much money or wealth this particular safe holds. Herfindahl-Hirschman index, or HHI, is a measure to help us understand how diversified a market or a safe is. So the higher the HHI, the less diversified the particular safe is. In terms of the weighted average volatility of assets, we want to measure the volatility of the assets in the safe. To do that, we'll just first get standard deviation of an asset's price in the past 3 months. So this way we can get the volatility for each asset, and then we'll get the weight for each asset. So it would be the total value locked of each asset divided by the TVL of the entire safe. And then we'll sum up the weighted average for each of the assets in the safe. That is the weighted average volatility of assets. And then the rest of the metric is pretty self-explanatory, so we're not gonna go into it. With that, let's get started with our SQL workout today. Okay, so going to Dune.com, going to start a new query, going to go to the Dune SQL engine, and then we'll just copy paste the metrics that we want to grab. And on the other side, starting my commenting block per usual in terms of total value locked in SD. So all assets total value locked, stable coins versus non-stable coins total value locked, and then the percent of total value locked in stable coin. In terms of diversification, we'll get the number of different assets in the safe, the HHI that we just went over, and the top 3 assets concentration ratio, so the total value locked of the top 3 assets divided by the entire total value locked in the safe, and then the weighted average volatility of assets that we just talked about. Okay, so logic steps per usual. First, we'll get the targeted safes. So safes created in the past 6 months. Then we'll get the balance of tokens. So this will include both ETH and ERC20 tokens. Here we're doing balance of each token. The next step is to sum up all tokens to get TVL, stable versus non-stable. Here we are also going to get the number of assets in the portfolio or the safe. Next up, we'll need to find the volatility of each assets in the safe. That would be getting the standard deviation of all the assets. And we are going to use the prices.usd table to help us get the standard deviations. Once we get that, we are going to sum everything up together to get all the previous metrics that we said that we would get. So this would be bringing everything together to get the metrics listed. Okay, let's get started. Because when we're looking at the total value locked, we are caring about the token flow of things. There's a lot we can borrow from the previous query we've written, so I'm going to go do that. Go into my creations, go to the activeness and usage stats that we wrote previously. First off, we can already grab the safe address block that we've written. This block gets us all the safes that were created in the past 6 months. Going to comment that out and going to take the same approach. I use one safe as a QA checkpoint, and then later on take all the safes that we care about. This is the volume block, and most of the things that we need, we can just copy from here. ERC20, and then all the assets as well. Okay, cool. So let's format this. First of all, instead of the ETH volume or anything that has the underlying volume, we're gonna change it into balance because we care about the inflow and outflow in a net way and not in a inflow plus outflow also plus way. Okay, we are going to do this with ETH balance as, and inside of this block, so ETH in is the same, ETH in, it would be a positive sum up. Here we need to transform this a little bit more. We care about transfer in the entire history, and we also know that the earliest time it could have happened was 6 months ago because that's what we're grabbing. We're grabbing all the safes that created from 6 months ago, so we could just say that. So greater than, okay, and anytime we have this, we are going to replace with that. So I'm just gonna search for it and already replace it. Okay, so coming back to ETH in, so that is ETH in, and then same thing for ETH out, except this time we treat out as a minus, right? So we're minusing it by -1. Then same thing, sum up ETH both, then can sum up the both together as the sum. That is our ETH block. Then same thing for the ERC20 block. We can do this. Here, remember previously we take the absolute value because we treat outflow also as positive, but here we no longer need to do that. We're going to remove the absolute function. I don't think we need to change anything else. Yep, so that is our ERC20 balance. Next step, we are going to join all the assets together in this block. So this is the all assets block. Oops. The all assets block. So all the assets, we're first going to take the ERC20 tokens, then adjust for the USD balance amount. That would be taking it prices to USD latest and then adjust it per contract or per token. For ETH, we treat it a little bit differently. We're going to use wrapped ETH as the price for ETH and then assign placeholder 0xEE as our token address and ETH as our symbol. We also know for sure that ETH is a non-stable coin, and then here we leverage on a different query to find whether the particular token is a stable coin or not. That is our all tokens. So let's do a QA check at this point. To make sure we got it right. Clearly we did not. Let's see what's wrong. Aha, missing a comma. Okay, looks like we have some results. So in this wallet, we've got some ETH and USDC, and USDT is a 0. So let's go check it to see. Etherscan, and then this is our QA address. We've got 0.41 ETH, 0.41 ETH, and then USDC 150-ish, USDC 150-ish. Perfect. Amazing. That's all correct. Next up, we are going to sum each of the token up and get the total value locked and different ratios. We're going to call this summing as. So select from all assets, and we want the safe address because that's still the group by unit that we care about. We want to count all the token address, so this would be the number of assets in this safe as num assets. And then next up, we need to sum up the sum USD amount as our total value locked. Next up, we are going to sum this up again, except this time we're doing a filter for where the category is equal to stable coins, and then this way it is our stable coin TVL, and then going to copy paste this and say non-stable coins, and then also this would be non-stable coin TVL. And then, as we said, we want to group by the safe address, so group by 1. Next up, we are ready to get the volatility of all the tokens that we are looking at, and we are going to grab that by looking at the prices.usd table and get the standard deviation. Here, we're going to call it all assets standard deviation as what? So again, we need to have 2 separate sections, one for the ERC20 tokens, one for ETH using wrapped ETH as a proxy, as we did for our balance. First off, we need to get the prices.USD table. We're going to call that P, and then as usual, we're going to limit the blockchain to be Ethereum blockchain. We've done this a lot of times. And then we are going to limit the token address to be the ones we only care about. So going to do a where exists, because eventually we expect more than this one QA address. So there will be a lot of token addresses we're looking at. So where exists should be faster. Select one from, and here we want to do all assets A, where A dot token address is equal to our P dot contract. So matching up the contract address with the token address here to filter for the price we care about. Then we're going to filter for the prices in the past 3 months. So P dot minute is greater than now minus interval 3 month. What do we actually want from here? So we want the contract address, and then we want the actual minute, and then we want the actual prices. And then we're gonna order by 1 and 2 so that it's forcing it to be in the same order, because we're trying to do a standard deviation. So the order of timing really matters. So this is for our ERC20, and then we're going to apply a standard deviation function on top of it. So we're going to do select from, and this would be the subquery we are selecting from, just formatting it a little nicer. You have to name a subquery, so we're going to call this T, and then here we're going to say select contract address. This is our token address, and then we are going to find a standard deviation function, so stdev, and then sample on what is our input value would be the price here, and then we're going to call this standard dev price. Going to finish up by saying we are carrying the standard deviation per token. Next up, we are going to do a union all and find our standard deviation for ETH. We're going to copy paste this block here and then paste it here. So here we know that we basically need the P contract address to be the same as wrapped ETH, right? So we are going to find wrapped ETH. So we need to get the address, which is here, and then we need to get the token address to be this filter address. First, we need to say this as our token address, and then here already filtering for using wrapped ETH for wrapped ETH for ETH. So let's change this to be T2 and then group by 1. This should be our all assets standard deviation. Now let's just quickly test out the standard deviation. So select star from all assets standard deviation. So we have the volatility or standard deviation for these tokens. We know this is ETH, 188 standard deviation, and these are our stable coins. Very small standard deviation. Makes a lot of sense. So let's move on. Now we're gonna take everything that we've done and join it together to get the various metrics that we said we will get. Going to literally call this join one as our CTE. Okay, so first off, we're going to do select from. Where are we selecting from? We're gonna select from the summing subquery, CTE, going to call it S, because we need all these ratios. We need to get all assets subquery and the standard deviation subquery. So going to do a left join on the all assets. I'm going to call this A on A dot. The safe address is equal to the safe address. Then also doing a left join on the standard deviation std on std.token address is equal to the token address in all assets. With that, let's grab the columns that we would want. First things first, we want the safe address. Then we want the number of assets that we already grabbed. We want the total value locked that we already got. Then we want to get stablecoin and non-stablecoin side of things. Sometimes it could be null and we want to just make it 0 in the case it's null. So we're going to apply coalesce and then s.stablecoin.tvl. If it's null, then it's 0. And this would be our stablecoin TVL. Same thing, coalesce on s.non-stablecoin TVL. If it's null, then it's a 0. And that will be our non-stablecoin TVL. Okay, and this is the part we get the ratios. Remember, we were talking about HHI. So HHI, Herfindahl-Hirschman index. The formula would be the market share firm 1 squared plus the market share of firm 2 squared, etc., etc. Here, taking the formula, we just need to find the market share of each of the token and then square that and then sum that up. Step 1, let's find the market share for each of the tokens. First of all, I already know each of the tokens total balance is the sum USD amount. So that's each of the tokens balance. Then we want to get the market share of that token. So we need to divide it by the total value locked. That's the entire balance of the portfolio. So this gives you what percentage of the pie this token holds for that particular save. Then this is a percent, because as you see here, the unit is in percent. So we are going to time that by 100. So that is the market share in percent term. Then we need to square, because you can see that we need to square this market share percent. So we are going to apply the POW function and then to the second power. So this is each of the individual market share for the token, and we need to sum up all the tokens market share, squared market share for the particular save. So we're going to apply a sum function, and this is our HHI. We want to get the weighted average volatility of assets. Here we want to get the weight for each asset. So same thing here, this is the weight of each asset, the proportion of each token in this particular save. Then we get that, and then we want to time that by what? Time that by the volatility of each token, which is the standard deviation for each token. So std.standard deviation price for the particular token. Once we get that, we are going to sum up the weighted volatility. So apply a sum function. That will be it for HHI and weighted average volatility of assets. One more thing that we need to do out of all the metrics here is we need to find the top assets concentration ratio. But to do that, we need to get a ranking of what's the top assets. So we're not able to do it here. We need to have yet another CTE to get the ranking and then grab the top assets. But other than that, all the metrics we wanted were done in this join one CTE. Before moving on, let's just run this. Okay. We forgot to do a group by, so let's do group by 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Actually, one more thing, we want to get the percent of stable coins as well. Let's do that. This divided by the s.tvl. would be the percent TVL in stable coins, because that's what we said we will do. Okay, one last thing, we are gonna filter noises out. So we're gonna say, unless you have 1 cent in your save, we don't care about you. That's what we're going to do. We are filtering out the noise. Then we're going to let it run. And then while it's running, let's just build out the ranked subquery because we need to rank the assets and then get the top n assets. So ranked as select from, we want to do this from all the assets we already grabbed. So save address, and then we want to get the token address as well. And then we want to get the sum USD amount for each of the token. And then we want to apply a Windows function. So we will do a row number function over, what are we partitioning by? Partition by the safe address, and then order by the sum USD amount within the safe address in a descending manner. And then this will be our row number. And with that, we can then join really everything together in our final part of the query. So select from join one. So this is our J, and then we are going to do a left join on this ranked CT that we just created on the safe address equal to each other's safe address. Then also we said that we want to get the top 3 assets as our top n assets here. So we want to have the row number less than or equal to 3. So that's how we get the top 3 assets. And then you can do top 5, top 2, whatnot. Let's start listing our various metrics that we want. Actually, before we do that, let's just do the most important part, which is to find the top n assets concentration. So we're gonna sum up the sum USD amount for these top n or top 3 assets, and then we're gonna divide that by the total value locked. So that is our top n asset concentration ratio. Now we are ready to get j.safe address, basically all the variables that we already listed. Num assets is also what we want. Total value locked, and then stable coins total value locked, non-stable coins total value locked, and then percent total value locked in stable coins, and then HHI that we just did, and then we have the weighted average volatility of assets. Because we're still doing a group by of the top n assets, we got to finish up the group by. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now let's test it out with the simple address that we have. And our row number is less than or equal to 3. Looks like we have some result. HHI is pretty high. Makes sense. It's not very diversified, really. So sanity check on this QA address passes. What we're going to do is we're gonna clean this up and put back the saved in the past 6 months. We're gonna comment this out and then use all the saves and then start running, then do a save. And then we're gonna call this safe wallets TVL and diversification stats. That is all for today. In the next video, we'll talk about how to combine all 3 queries that we've written so far into a dashboard and how to create visualizations and create a coherent story on all these data points that we've secured. See you in the next video. Bye!